You know, the universe is just full of mysteries. But honestly, none are quite as dark or as deep as black holes. They're like the ultimate cosmic crime scene, right? You've got this invisible suspect with a pull that's totally inescapable. So today, we're going to put on our detective hats and go on the ultimate cold case, hunting for clues to find something that, by its very nature, can't be seen.
And that really is the central question for any black hole hunter, isn't it? I mean, since they don't give off or even reflect any light, you can't just point a telescope at the sky and spot one. So how in the world do we prove they even exist? Well, it's all about looking for the clues they leave behind.
But before we can find our cosmic suspect, we need to know what we're looking for. We got to understand its basic anatomy, its MO, if you will. It really all comes down to one word: density. Okay, try to imagine this. You take a star that's 10 times more massive than our own sun, and you squeeze all of that matter, all of it, down into a sphere that's roughly the size of New York City. What you get is gravity so ridiculously powerful, it doesn't just pull on things, it actually breaks the rules of space and time all around it.
And this brings us to the event horizon. Now, this isn't some kind of physical surface you could stand on or touch. It's the point of no return. The best way to think about it is like the edge of a cosmic waterfall in space-time. Once anything crosses that line, doesn't matter if it's a planet, a star, or even light itself, there is absolutely no turning back. It is the ultimate one-way trip.
All right, so now that we've got a profile of our suspect, how do we actually catch it in the act? This is where scientists basically become cosmic detectives, and they use some incredibly clever tools to gather the evidence.
So, here's the detective's toolkit. First up, you look for the fingerprints. See, as gas and dust get pulled in, they form this superheated, swirling thing called an accretion disk, and it glows incredibly brightly in X-rays. Second, you track the witnesses. If you see a star just whipping around an empty patch of space at impossible speeds, well, you know something massive and invisible has to be there. Third, you listen for the tremors. When two black holes collide, they literally send out ripples in spacetime itself. We call them gravitational waves, and we can now actually detect them here on Earth. And finally, you use the suspect's own power against them. A black hole's immense gravity acts like a giant lens, bending the light from distant galaxies that are behind it and giving its position away. Pretty clever, right?
Okay, so black holes are huge stars in science fiction, which, of course, means there are a lot of myths out there. So let's take a minute and separate the real science from the sci-fi fantasy.
This is probably the biggest misconception. People imagine black holes as these cosmic vacuum cleaners just sucking up everything in sight. But they don't suck. From a safe distance, their gravity is exactly the same as any other object with the same mass. Here's a cool thought experiment. If our sun were to just instantly be replaced by a black hole of the exact same mass, Earth wouldn't get pulled in. We'd get very, very cold for sure, but we just keep on orbiting it perfectly fine.
And that brings us to the second big myth, that black holes are these super rare monsters. The reality? Well, they're basically a standard feature of the galactic blueprint. Astronomers now believe that pretty much every large galaxy, and yes, that includes our own Milky Way, has a supermassive black hole right at its center. Ours is called Sagittarius A star, and it's kind of a quiet giant, weighing in at about 4 million times the mass of our sun.
Now for the really fun part, let's pull up the rap sheet for some of the most extreme black holes ever discovered. I mean, these are the true record breakers of the cosmos. First up, let's meet the heavyweight champion of the universe, a beast called TON 618. This number, 66 billion, that's its mass in solar units. That means it weighs as much as 66 billion of our suns put together. To even try to put that into perspective, if you placed it at the center of our solar system, its event horizon would swallow every single planet, all the way out past Neptune. This thing isn't just a black hole, it's an ultramassive black hole, a true cosmic titan. Okay, so now let's go from the absolute biggest to the smallest. This little guy, nicknamed the Unicorn, is the lightest black hole ever found, at just 3.8 times the mass of our sun. Now, don't get me wrong, it's still incredibly dense. You're crushing all that mass into a space only a few miles across, but it really shows you the incredible range these things can have, from the size of a city to the size of a whole solar system. So this next one isn't about mass, it's all about speed. The black hole GRS 1915+105 is a cosmic spinning top. That number, over 1,000, that's how many times it rotates every single second. Just think about that. For an object with more mass than our sun to spin that fast, it's almost impossible to wrap your head around. The edge of this thing is moving at over half the speed of light.
And if you ever did get too close to one of these objects, well, you'd experience this. And yes, spaghettification is a 100% real, honest-to-goodness scientific term. The gravity at your feet would be so much stronger than the gravity of your head that you'd literally be stretched out like a noodle. It's a very vivid and maybe slightly terrifying reminder of the extreme physics we're dealing with here.
So our cosmic detective story concludes not really with a final answer, but with an even deeper mystery. We now know that these invisible giants aren't just weird anomalies. They're a fundamental part of how the universe is built. But that discovery just raises the next, bigger question. If every single galaxy has a monster like this hiding at its heart, what else is still out there, waiting in the dark for us to find?